script. Okay, so today we're going to continue with lenses. So we will finish them, and then yeah. So we're going to continue with lenses. I just want to remind us what we did last time. We said lenses look something like this. This would be converging or diverging. Convex, which means convex.
Oh, converge.
It will converge.
Converge, convex. I think I figured it out.
Or converging in this case for lenses. For mirrors, though, a convex mirror is diverging. Because when you hit the back of the mirror, it diverges. But this one, the light actually goes through. So this is the axis, and this is the focal point. And if you send rays like this, they will converge. If you send another ray that's parallel, it will converge. If you send another ray here, it will go through the focal point. If you send another one here, it will go through the focal point. They all get focused here. This is the focal point. And if you send them here, this way, there is another focal point here. Or two, one from either side. Because the lens is transparent from both sides. Okay. That's the convex converging lens. For the diverging lens, here's F, here's F, and for that one we said if you send a ray that is parallel, it will get diverged. How does it get diverged? In this direction. If you send another one this way, it will get sent in this direction. And send another one. Like that. Okay. And you can draw them. The book has better pictures than the ones I have. And then we talked about the radius of curvature and the index of refraction. So if this is the lens, like so, it's cut from something like this, this side, something like so. This is R2, and this one here is R1. R2 is all the way here, and then R1 is here. In this case, R1 is equal to R1, and R2 is equal to R2, negative. R2 is negative. Let's draw more rays. I want to derive the, last time. Here's what we got. We got the following equation. We had this from last time. 1 over S plus 1 over S prime is equal to N minus 1 times 1 over R1 minus 1 over R2. Okay? This is from last time. So today I want to get a similar equation to this, but relate the focal point to S and S prime. S is the distance, is the object distance, right? And then this is S prime, it's the image distance. So let me, maybe I will draw here. Let's draw here. So let's consider a lens here, and then ask about where the image is going to be. Here's the lens. Here's F on either side. I'll try to be as accurate as we can. And then let's make our object right here. And this is S, right? That's the distance from the object to the lens. The height of the object The book calls it y, so I would call it y also. Now, let me send a ray that is parallel. Where would that parallel ray go? Through the focal point, good. So that ray would go through the focal point. So, next, I can draw another ray this way through this focal point. I can draw another ray through this focal point this way. And then ask, how would this ray go? It will go parallel, because if you send it parallel, it will go through the focal point, yeah. It will go like so. And let's send the one through the middle, through the center. What happens to the one that goes through the center? It goes straight through, right? It will bend, but then when it just comes out, it will be just straight. So, just draw it straight. And if I did everything really accurately, they're supposed to meet here, okay? They're supposed to meet here. This is where the object forms, the image forms. This is y prime. Notice that y prime is negative. Y prime has a minus. It has a negative value. Maybe it's minus 3 centimeters or something. That's, so now, what's this distance from here to here? What's this? That's y, yeah, this is parallel, yeah. Right. So here's what I'm going to do. I'm going to name this angle here theta. So this angle will also be theta, right? You agree with that? Okay. So notice the following. The tangent of theta is equal to what? Tangent of this angle is the opposite over the adjacent, right? The opposite is y. What's the adjacent?
2m. S.
This, yeah, s. So it is y over s. On the other hand, let's look at theta from here. This distance is what? Y prime, but it's negative, so I want it to be positive. What do I do? That's it. I have to put minus y prime, right? And then over this distance. What's this distance? This one. What do you say?
S prime.
Yeah, s prime. That's the image distance. So s prime. So that means this. That means if I combine these two together, I will get the following. I get minus y prime over y will equal to s prime over s. Agree with that? Right? You could just modify it to become this. Let me call this here equation 1. Now next, let's look at the other angle, which is this one. Let me name this angle here phi, and this angle here phi. Okay, what's the tangent of phi? Let's look at this triangle first. This triangle. What's tangent of phi? You can tell me.
Square of
Y over this much, right? How much is that much?
negative m.
What's the distance from here to F? It's F. Yeah. It's the distance to the focal point. Yeah, it is F. So we said what? Y over what?
Negative. Is it negative?
Actually, just F. A converging lens will always have F is positive. For diverging, F will be negative. But the same equation applies. You just have to put a minus sign for F. We'll do an example. We'll do 2 or 3 examples. Okay, let's look now at phi from this side, this one. So now this, so it would be what? This side, which is y prime, but I have to put minus, right? Minus y prime, because it's inverted, over this distance. What's this distance?
S prime minus f.
Yeah, this distance would be the whole thing, which is s prime, minus this much, which is f. Yeah, so it's s prime minus f. Let's do the same thing. So here I have minus y prime over y is equal minus y prime over y will equal to this over this. Would be s prime minus f divided by f. Do we agree? So let's call this equation 2. And now let's combine equations 1 and 2. Equations 1 and 2, and let's see what they give us. Equation 1 says minus y prime over y is this. Equation 2 says the same quantity minus y over y prime is this. So I'm going to set the right hand sides equal to each other. So I get s prime over s will equal to this one here. This one you have s prime over f. Right, I'm going to just break the fraction. Minus, what is f over f? Just 1, yeah. Let's divide both sides by s prime. Divide everything by s prime. So if I divide this side by s prime, what do I get? What's left?
1 over s.
1 over s. If we divide by s prime here, I get
1
over f
minus 1 over s prime.
minus 1 over s prime. Move the s prime to the other side, you get 1 over s plus 1 over s prime is equal to 1 over f. Have we seen this equation before? Yes, for mirrors. It's exactly the same equation, and it works for both, and we just have to use the right sign convention. For converging lenses and mirrors, f is positive. Diverging lenses and mirrors, f is negative. And so this equation deserves a box again. And this equation also maybe deserves a box, maybe not. But let's look at the left side of this equation says 1 over s plus 1 over s prime equals to something. And this one says 1 over s plus 1 over s prime is equal to something else. So what can you conclude about the right-hand sides?
They're equal.
Yes. So we conclude also that using that equation, that 1 over f is equal to n minus 1 times 1 over r1 minus 1 over r2. This is the lens maker's equation. Lens maker's equation. I think probably it's true. They call it the lens maker's equation. I guess if you want to make a lens of a certain focal length, you need to know this equation. That's how you cut your lens. Make a radius this and the radius that, and then you can figure out what f is. All right, to the examples. So suppose we have here a lens, also example 1. So suppose we have, you see that one over there, that lens? Suppose R1 is equal to R2, and they're both 10 centimeters, okay? Both are 10 centimeters. You see those? R1 and R2, they're both 10 centimeters. And let's say the index of refraction, the material we're using is has an index of refraction of glass, let's say, which is 1 point, let's make it 1.5. Okay, that's the index of refraction. The book, they say 1.52. For simplicity, I'm just going to use 1.5, all right? And the question is, what is the, what's f? Find f. Calculate. Okay. So solution. Who can tell me what R1 is? I gave you the absolute value of R1, but R1, is it 10 centimeters or minus 10?
10.
Just 10. R2, minus 10. Therefore, we have 1 over f will equal to n minus 1 times this combination. Okay? We get n minus 1. N is 1.5 minus 1. Okay, 1.5 minus 1 times 1 over 10 minus 1 over minus 1 over 10, right? Don't forget the minus minus, so it becomes twice. Okay. So we get 1 over f. 1.5 minus minus 1 is a half. It's 1/2. Right? Times 1 over 10 minus minus 1 over 10 is just 2 over 10, right? So 2 over 10. And so we get f equal to 10 centimeters. Probably 10 is a poor choice because they came out to be the same number, but that's fine. We could have chosen 8 or 20 or something like that. All right. And also the index of refraction doesn't help, that it's 1.5. It would just be half of 2, which come out to be half. Anyways, that's that. So if you're asked, yeah,
The circle
Yeah.
that's on the left
Yeah.
is always going to have the negative radius.
the circle, assuming the light is incoming from the,
The left.
yeah, from the left,
Oh,
yeah. It ends up being the same way, yeah. So what happens is, if one of them is positive, the other one has to be negative. Let's see. We will do the next example. So let's say we have a lens, a convex lens. Suppose we have example. Consider a convex lens. By the way, if you're using the lens maker's equation and you have a lens that's convex, the focal length should always be positive, right? So if you get a negative number, you know you have done some mistake.
So you're saying the F is positive for mirrors and lenses.
If they're converging, yes.
Okay, so both converging mirror is
Converging mirror is convex.
okay.
I'm sorry, a converging mirror is concave. Yeah, a mirror that's converging is concave.
Okay.
If it's a lens.
It's a lens, it's convex, yeah. Yeah. So as long as, if both are if it's converging, F is positive. Okay. So a convex lens means what? Conversion? Yes. So conversion has F equal to 20 centimeters, and I'm going to emphasize positive 20 because it is convex, it's conversion. And the focal length is that, and we're asked to find the image position and the magnification for different object distances. So find S prime and M for this, for the following cases. Let's go for case 1. Let's say the object distance is 50 centimeters. If the object distance is 50 centimeters, let's first find S prime. So how can we find S prime? That equation, yes. So it's fairly easy. So you do this 1 over S plus 1 over S prime is equal to 1 over F. And this is handy if you just move 1 over S to this side, make a common denominator, flip the fraction. This is handy. You have this S prime will equal to this S times F over S minus F. This is just nice. You just have it. Okay. Okay. I moved it, common denominator, flip it, and you get this. So then in order not to make a mistake, always make parentheses, although in this case, f is positive, so s is 50. Everything is in centimeters, so the answer will come out to be centimeters, 20, and then 50 minus 20, and we get 30, I think, yeah, 30, let me just, 33 and a third centimeters. That's S. I'm sorry, S prime. That's S prime. Now the magnification, the height, or the ratio of the two heights is magnification. Do you remember what it was?
Image distance.
It's S prime over S, but there was a minus sign. It's minus S prime over S, and it's equal to minus 33.3 over 50, and so we get the magnification will be minus 2/3, or 0.66, minus 2/3. That's the magnification. It means the image is going to be inverted, right? It's going to be inverted and reduced. Reduced means smaller. Inverted means upside down. Okay, is that clear? Let's go to part B. Let's say now the object distance is at 20 centimeters. Let's say if S is equal to 20. Notice, if S is 20, that's the same length as the focal, right? It's the focal point. If it's, you will have 20 minus 20, which is 0. And so you'll be dividing by 0, and that's infinite, right? What it means is, if S approaches F from the right, you're slightly greater than F. You will get an image that forms at infinity, positive infinity. It would be a real image, but at positive infinity. And then if S is slightly less than F, then S prime will be negative, and it will approach negative infinity, right? As you approach F from the left. And so it will be at minus infinity. But if it's exactly at 20, it's undefined. The book just says S prime is plus or minus infinity. Okay? We don't. Either way. Which is kind of unrealistic to say, because first of all, we made all kinds of approximations, right? And if you put the object at exactly the focal point, first of all, you're never exactly there. The object always has some width. So you're never, there is no two-dimensional object, it's just zero width. But anyways, it will be far, and that's enough for us. Far means, if the lens is here, you're a couple meters away, that's far. That's infinite. Okay? Or maybe the back of the classroom or something. The magnification will be either plus or minus infinity, right? The image will be large. Be very big. Okay. I'm going to just do one more, and then I will ask you a question. C. Let's say the object is at 15 centimeters. S equals to 15 centimeters. That means S is less than the focal point, right? Less than the focal point. In that case, it's going to be what kind of image? A virtual image. So let's, this one we predict it's going to be a virtual image. Let the math do the job, and then we will, I'll show you how to plot it. So you get S prime will be SF, so 15 times 20 over 15 minus 20. 15 minus 20 is minus 5. 20 over 5 is 4, 60, so minus 60. Is that true?
Yeah.
Yeah, minus 60 centimeters. And what would the magnification be? Magnification would be minus 60 over 15, and that's equal to 4, isn't it? So the magnification will be positive 4. Be positive 4. Let me draw it. So if we have, so here is the length. Here is F. This is F. This is F. So F is at 20, and we place our object at 15, right? So if this is 20, this is 10, so 15 would be here. Agree? Around. So I'm going to draw my object here, and I will draw my object this big because I anticipate the image to be 4 times as large. So here is the first ray. First ray is going to go parallel. Where would it go afterwards? Focal point. Okay, let's try to. I'm trying to be as accurate as I can. So that's the focal point. The other one, let it go through the center. They're diverging from each other. They won't meet, but here is their extension. Somewhere here, right? That's their extension. And so it's a virtual image because it's not on the same side as the outgoing rays. So this side, and it's about 4 times. And it's upright. Magnification is positive. Okay. I have a question for you. Where would you place an object? What should S be? Okay, suppose for a converging lens, focal length is F. Okay, suppose for this one, focal length is F. We don't need to do F to be 20 or whatever. I would just leave it as F. Where would you place the object? Meaning, what is S? So that the magnification, the image will be real, and it will be as big as the object.
Between the middle, the focal point and the.
So here's what I want. Right? So let me write it. So given F, and F is positive, right? It's a converging lens, so F is positive. What should S be? S be so that we get a real image the same size as the object.
So M equals 1?
I'm purposely being vague whether it's +1 or -1. It's the same size. It could be inverted. So we need to figure out. We need to figure that out. So here's the magnification. Magnification is minus S prime over S, right? If the image is real, it means S prime is positive. Okay, and we have a real object here. So S is positive. So we get the magnification to equal to -1, right? So the magnification has to be negative. Because S prime is positive, S is positive, and I want, so I have a minus sign here, I can't do anything about it. So magnification is -1, which tells me then S prime is equal to S, right? S prime is S. Okay. So that means 1 over S prime plus 1 over S is equal to 1 over F. But S prime and S are the same, so 1 over S plus 1 over S is equal to 1 over F. So that means twice over S is equal to 1 over F. And that means S over 2 is equal to F. and that means S will equal to twice F. So if I place my object at twice the focal length, I would get an image. It would be inverted, but the same size as the object. Okay. And you probably can guess. I mean, where would you place the object so that you get an image that is real and maybe 1/3 the size of the object? You can do the math. Let's do the next example. It would be a diverging mirror, diverging lens. Does anyone have a question on this? No? So we'll do the next example.